En economía no se puede utilizar.
In economics, we cannot use probability calculations, nor Bayes' theorem. You might respond, but Professor, everything they teach us here has to do with statistics and probabilities. And they give us an operation designed to help us solve concrete problems in a company.
Solucionar problemas concretos en la empresa. Yo me acuerdo que
I will never forget a marketing class in which the professor said, the demand function for the cars a company produces is, and he put it in front of us, and market research has determined that it is going to change to this. Calculate the number of cars the company will sell. And everyone got busy calculating, and out popped an answer. The result, the number of cars that would be sold. And I raised my hand and said, excuse me, but that doesn't make any sense, because if things worked that way, no company would ever fail. They would all be successful. We will see that neither demand functions nor probabilities are applicable, nor can they be calculated. Market studies are useless. Why are they done then? For the same reason horoscopes are written. People ask for them. You want them and you're willing to pay? I'll do them for you. I've got to eat too. Market studies give people a false sense of security. It is very important that we distinguish between two different concepts of probability. In human action, Mises calls them class probability and case probability. We must distinguish between them because we constantly speak in human terms and in terms of the actions of probability. In the world of the natural sciences, the applicable concept is that of class probability. What does class probability mean? It means we know the behavior of a set of phenomena, a set of elements, but not the isolated behavior of each element in the set. For example, we know that 3 people out of every 1,000 who are 40 years of age will die next year. If you take a set of 1,000 people who are 40 years old, you know that 3 will die. But you do not know the exact first and last name of the unfortunate ones. When there is a set of elements that are homogeneous phenomena, and we know how they behave as a class, as a whole, but not the isolated behavior of each individual element, the applicable concept is that of class probability. This is the concept relevant to the sphere of the natural sciences. If we have a fair, 6-sided die and we throw it 1,000 times, each side will land up approximately 1/6 of the time. We do not know which side will land up on any one throw, and the way we express that we do not know is to say that the probability is 1/6. We know how the set behaves. If we toss a fair coin in the air 1,000 times, our outcome will tend to be heads half the time and tails half the time. We do not know what the outcome of any single toss will be, but we do know the behavior of the class. This is the concept of probability that applies to the world of the natural sciences. And this concept of probability gives rise to the idea of risk. The idea of risk is the province of the natural sciences. There is risk we can calculate in terms of probability. My risk of death is 3 out of 1,000, because I know that 3 out of a set of 1,000 people to which I belong are going to die. I do not know if I will be one of the unlucky ones, but I run a risk which can be measured by class probability. This risk can be expressed mathematically. It can be dealt with from the perspective of probability theory. And furthermore, it is insurable as part of a class of phenomena. Indeed, I do not know who the unlucky ones will be. I do not know which specific 3 people will die, but I can insure their lives. If there are 1,000 people and each one contributes €3, then 3,000 euros can be set aside in a pouch, and later 1,000 euros can be given to the heirs of each of the people who die. In that way, they have been insured against loss. If I know that 1 out of every 100,000 homes is going to burn down, I can insure myself by paying a premium. A fund is created, and when it is known who has drawn the short straw, the insurance company compensates that person. The risk is insurable as part of a class of homogeneous phenomena. The concept of probability is applied to a situation of risk, which means we know the behavior of the class, but not that of its individual members. The concept of class probability is an essential object of research in the sphere of the natural sciences. There are different ways of approaching it. There is a logical concept. the number of favorable cases divided by the number of possible cases. For example, heads or tails, 1/2, 50%, or one side of a die, 1/6, or 3 deaths out of every 1,000 people, 3 divided by 1,000 in a mortality table. This is the logical concept of probability, or the frequency concept. I toss the coin 1,000 times, and if it is a fair coin, the outcome will tend to be something like 498 and 502, heads or tails. And the more times I toss the coin, the closer the two numbers will come to each other. It is essential that the elements be homogeneous, that is, that they be entirely interchangeable. This is the concept of probability in the world of the natural sciences.
del mundo de la ciencia natural.